Sadly, most of the efforts in biomass to energy tend to focus on the ones with great sex appeal, and that is advanced biofuels to diesel fuel or to ethanol or to gasoline. While we're spending all this time and effort on these high-tech, sexy approaches, we tend to ignore the most cost-effective use of biomass, and that is taking waste biomass and blending it into existing coal plants. Because these are sunk investments, the incremental cost of these capital-wise are very small. You just dump this and blend it with the coal right into the coal-fired boiler without essentially any investment, up to perhaps 10% of the energy, which would limit the supply of the biomass anyway, because the coal plants are so large and the biomass supply that's in, let's say, a radius of 50 miles of the plant is relatively small. So biomass co-firing is very effective. It's generally the supply of the biomass will limit the amount of biomass that you can blend. But if you're in an ideal location in the middle of forestry operations where there's a lot of biomass, then there'll be physical problems associated with reactive sodiums affecting the superheat reheat of the traditional boilers. That's for existing pulverized coal boilers. Also, crushing the biomass becomes onerous at more than 10%. However, for new plants, you can build fluidized bed combustion, and they're doing this in Sweden. In Finland. Finland has a circulating fluid bed combustion that's 200 megawatts of electricity that's designed to go from 100% coal to 100% waste wood biomass. So with fluidized bed combustion, it's very easy to effectively co-fire more biomass with coal, but generally the supply of the biomass will limit that to 10% because the coal-fired pulverized coal plants are so large. If you're burning 100% biomass, because of the moisture in the feed, it's very low efficiency, down less than 30% efficiency generally, plus because of reactive sodiums in the biomass ash, they tend to have very low superheat temperatures for the steam as well. So a 100% biomass plant will be very inefficient, generally less than 30%. Whereas if you just blend that biomass into a coal-fired plant, it'll be up in the range of 35% efficiency minimum, just because the reheat, superheat temperatures are higher. And then if you design effectively, you can get up in approaching 40%. So relative to 100% biomass, once you blend with coal, you can get much higher efficiency in spite of the moisture content of the biomass generally being higher.